All right, section 4.6 is on historical and exponential depreciation. Exponential depreciation is when the value decreases by the same percentage each year at a decreasing rate. Here's the formula that we're going to be using for this section. Y equals A times 1 minus r to the x, where x is the time, r is the rate as a decimal, and A is the value or the monetary cost. Number 1, Seamus bought a car that originally sold for $40,000. It exponentially depreciates at a rate of 7.75% per year. Write the exponential depreciation equation for this car. So Y equals A, which is the value of the car, $40,000, times 1 minus the percentage as a decimal, 0.0775 to the x. Number 2, Chris purchased a used car for $19,700. The car depreciates exponentially by 10% per year. How much will the car cost or be worth after 6 years? So Y equals $19,700, what the car was bought for, times 1 minus 0.10 for 10% to the 6th power. Okay, x is the time in years. Plugged it into the calculator, all right, and you'll get a value of $10,469.39. Question 3. The car that Deanna bought is 8 years old. She paid $6,700. This make and model depreciates exponentially at a rate of 14.15% per year. What is the original price when the car was new? So here we're working backwards. So our Y value is what the car, what she paid for the car. So $6,700. Okay. We're going to work backwards now. Our A value, that's what we're going to try to find out. 1 minus the percentage, 14.15% as a decimal, is 0.1415 raised to the 8. Okay. From here, we can do the work inside the parentheses. So 1 minus 0.1415 gives you 0.8585 to the 8th power. Okay. Divide both sides by the non-A portion, 0.8585 to the 8th power. Divide both sides by that. So in the calculator, you're going to do 6,700 divided by 0.8585 to the 8th power. It'll give you an original value of $22,706.62. So there we're working backwards. We are trying to find out what the car was worth. Number 4. What is the exponential depreciation rate? So here we're going to solve for R. Expresses a percentage to the nearest tenth of a percent. For a car that was originally sold for $30,000, so that's your A value. When new, but exponentially depreciates after 5 years. 5 years is going to be your X value. And $18,700 is your current value. Okay? So the car was bought for or sold for $30,000. It's now worth $18,700 and after 5 years. So we're solving for R. Okay? So what you want to do here is divide both sides by 30,000. Okay, on the right side you have 1 minus r to the 5th power still. And on the left side, once you divide 18,700 by 30,000 gives you 0.6233. Okay, and then in order to get rid of a power, you multiply by the reciprocal. So 5, if our power is 5, okay, the reciprocal instead of 5 over 1 would be 1 over 5. So you're going to multiply both sides by 1 over 5. So that gets rid of your power. So on the right side, you're left with 1 minus r right here. And on the left side, 0.6233 to the 1/5 power. Okay. We're going to get r by itself. Okay, so you're going to subtract 1 on both sides. Okay, so we are left with this right here now. Negative r equals 0.6233 to the 1/5 power minus 1 gives you the decimal negative 0.09021. And we don't want a negative r, we want a positive r, so you're going to divide both sides by negative 1 on both sides. Okay, divide. Once you divide, you'll have r equals 0.09. We know that 0.09, if you move it 2 places to the right, gives you 9%. Okay. Number 5 we are not going to do. Okay, but number 6, we're going to use that y equals a times 1 minus r to the x formula again. It says a car originally sold for $25,900. That's your a value. Okay, it depreciates exponentially at a rate of 8.2%. That's your r value. And Nina puts down $10,000 and pays $550 per month to pay off the balance. After how many years will the car value equal the amount she paid for the car to that point? Okay, so your first equation, y1, is your a value of 25,900 times 1 minus 0.082 for 8.2% to the x. Okay, your second equation is going to be, she put $10,000 down. All right, so your y2 equation is going to be $10,000 plus $550 per month times 12 months per year, so 12x, gives you an equation of 10,000 plus 6,600x. So basically you're going to take those two equations and set them equal to each other. The biggest thing I want you to do is just try to come up with the two equations. So here's y1 equation up at the top, and in the blue, there's your y2 equation. Okay? So that's really all I wanted you to kind of get from question number 6. And that is it for section 4.6.